So, hi everyone. It's nice to see you in New York, in a place where everyone owns an iPhone. It's especially great to talk about Android development. And I don't think we're translating. Yeah, thanks. Today I'm going to speak about the Art of KMP, or what you need to know as a multi-platform developer, or what I learned about Android development and multi-platform development on my KMP journey. But first, let me introduce myself. My name is Lena. I live in Dresden. In summer, I play tennis. In winter, I like skiing. But regardless of the weather, I do mobile development. And that's the beauty of our job, isn't it? We can do mobile development no matter what the weather. My developer story started back at university. I had never programmed before, so it was quite a challenge. What is object-oriented programming? What is layout, toast, snack bar, activity, fragments, intents? How do I start a track on a button click, set on click listener? Okay, cool. How can I make it stop now? After having clarified all these questions, I built my first simple app, but there were still so many things to learn. And I have to tell you, I'm a big fan of planning, so I needed a learning plan. I started looking through Android documentation, forums, writing out all the words and concepts that I had no idea of, and I ended up with a list of interesting stuff. Then I Googled more and found several developer roadmaps, something like this. You can see it starts with you picking up a language, then learning the basics like data structures and algorithms, going on to version control and Android-specific topics, of course. And all of this can seem trivial to an experienced developer, but when you're a beginner, it's not. And almost 2 years ago, I felt like a beginner again, because there is this last section on the map where the path ends. And you don't know what to do next. At this moment, you have no idea how it should continue. In case you're wondering what that stone says, I have a translation. The vision of classic art is impressive. It's a great source for inspiration for tech talks. So I started researching on Kotlin multi-platform to keep learning. And from a developer perspective, KMP has quite a steep learning curve, because it's an upgrade from traditional Android development, and of course it's a complicated technology. Imagine how much effort it must have taken to create something that allows you to share it between different platforms, and not only iOS or Android, but also web, desktop, wearables, backend. However, as a developer, you may be more interested in implementing it. You want to use KMP to build apps efficiently. But to build an app, you need your tools, and you need to know how to use them. If it's a big app, you will also need a team. Of course, you can try using your old tools. You don't have to learn anything new, just stick to your old ways. However, there is one quote by the most amazing Grace Hopper. The most dangerous phrase in history is, "We've always done it this way." Grace Hopper, the inventor of compiler, was one of the most influential developers in history. She's a great inspiration, and I think this quote fits KMP very well. Yes, we can still use old tools and do it the way we used to do, but there are new tools, and sometimes they may fit the situation better. As an example, imagine you're moving into a new apartment. That actually happened to me last year, and you want to make it cozy, optimize it for yourself, so you start drilling holes in the wall. And you think it's easy, here's a drill, it makes holes in the wall, what can go wrong? But your assumption is that every wall has the same structure. Well, if you go this way, then you made up with something like this. It's a hole and it does what it's supposed to, it holds a wall block. But is it nice? Is it optimal? No. Had I researched how to drill walls properly, I would have known each wall structure requires a certain type of a drill. In other words, you can drill a brick wall with a regular drill, but it's painful, dangerous, and the result is ugly. Software development is just like that. You can use whatever tools you want to use, but some things just work better together, like a brick wall and a hammer drill. Compare these two outcomes. Would you rather your software look like this one or this one? You could also view them as expectation and reality outcomes. However, I think we should always strive for the expectation, no matter what. And if the reality is still ugly, then at least we did our best. So key point one, research before you start coding. Get your tools ready and know how they work. Last year, I gave a talk about my experience building 2 production apps with KMP. In my previous company, we initially decided to go with KMP because it would help us to reduce time and costs. Being a fast-paced software house, we realized KMP had several advantages compared to traditional development or other cross-platform frameworks. And in fact, it helped us to speed up the development and simplify the maintenance. But when we started, KMP was not even marked as unstable. It was experimental. And with experimental technology comes great learning effort. During a couple of years that I spent developing those apps and working on side projects, I could try out different libraries, tools, and architectures. And in this talk, I want to quickly revise on all important topics that are good to know for an Android developer who is moving to Kotlin multi-platform. Just like the first time I started learning Android, I wanted to have a list of topics and tools to help KMP beginners on their learning path. And then I decided to convert that list into a roadmap. Now that old Android map has a continuation and doesn't make you feel lost at crossroads when you want to keep learning. And believe it or not, the first topic I want to cover in my speech has also come up in several artworks, like this one. Or this one. So Gradle. Let's revise on the basic Android roadmap. There is this section, what is it and how to use Gradle. Gradle is a build automation tool. Well, that's a fancy title. Let's break it down. What does build automation mean? As a developer, you write code. For that code to actually work, you run it on an emulator or a real device. And before you run it, you build it. And that's where Gradle helps you. All the source code, all the resources you have, like strings and all the libraries, drawables, it combines them into final Android package or APK. We won't go further into the build process, but let's rather remember what Gradle files we have. First, different kinds of properties like Gradle and local. Here we use key value pairs to specify settings for the Gradle build toolkit itself. Then we have top level build file, which applies configurations to all the modules in the project. And that is something we come across in every project. And you may get away with the simplest structure in traditional Android, but in KMM, what you learned before will probably not suffice. KMP projects are multi-modular and require the understanding of such structure. Let's continue with Gradle files and look at settings. In Gradle settings, you specify all the modules used in your app. A regular single module Android app structure would simply have one module. And the dependency management is relatively easy. You have only one application level build file. But once you move to KMM, you already get at least one additional shared module. And if you want to go deeper into KMP, just take a look at the People and Space project with its numerous modules. Let's get back to Gradle files. The application build file is located in each module. Here you specify your package-related info like application ID or minimum SDK. And here you also add external dependencies. And as you can imagine, with every module you get another file with dependencies. But that's not it yet, because you have a shared module. And because it serves as an intermediary between Android and iOS, shared build file is special. Here you will probably do something you've never done before, even if you're used to working with a multi-modular project. First, you specify your targets, such as Android, iOS, or even more. And you can also configure CocoaPods for iOS. And then you have a long list of source sets to hold your multi-platform dependencies. And the more source sets you have, the longer is the list. Luckily, you don't have to write all the configurations on your own from scratch anymore. Since the KMM plugin, it's become much easier to start a KMM project. Of course, you still need to understand the structure of the project and how to configure your build Gradle files properly. Every project is unique, and there is a great chance that copy-paste won't work every time. We don't want our project to look like a bad hole in the wall. To sum up, if you're used to working in a modular project, then starting with KMM in terms of managing Gradle files will be easier for you. But if you're new to modular structure, it may seem complicated at first. But you'll get used to it, and maybe you'll enjoy it so much that you'll decide to break down your monolithic app into modules as well. You can imagine when you have this much in a project, it can get confusing. So it's important to stay organized and keep everything as clean as possible. As you know, generally we have at least two layers in the app. The UI layer that displays application data, and the data layer that contains the business logic and exposes data. The big advantage of KMP is sharing code for the data layer and leaving the UI to the platforms. You can also decide how much of business logic you want to share and choose your structure accordingly. For example, you can choose to share just the business logic, or you can also share view models. It's just that then you will need to find a way how to communicate between the view models and the platform UI. App architecture is in general a very exciting and dynamic topic. Architecture patterns come and go, and no one ever knows what's the best one. The history of Android architecture can be followed on this graph. First, at the beginning of Android, we had MVC, which basically splits the app into three parts. Model is responsible for data, view for the UI, and controller is the brains of the app, which does all the logic and communicates between view and model. Surprisingly, it stayed for quite a while because mobile devices were just starting to gain power over human minds, and the apps were relatively small. However, after it became clear that the future is mobile and the apps started to grow bigger and heavier with tech debt, we decided that MVC isn't the best pattern. It has interdependent layers and low testability. Around 2016, Android world moved to MVP. Here we have model, view, and presenter, which sounds quite similar. However, main difference is that unlike MVC, views and presenters interact through interfaces, which makes the views independent and the whole thing far more testable. It's still very present in many apps, but as you can see from the graph, in 2018, MVVM has become the latest fashion. It was the next step to reactive UI with observable live data holders. There's also this small purple line, which is MVI and requires defining and managing UI states in Europe. However, even though it appeared not so long ago, it didn't gain much popularity because of its relative complexity. As for KMP, I've been looking at projects and trying different approaches, and I cannot say there is one recommended architecture. Of course, everyone has their preferences. If you love MVVM, then you will probably go with it, and it works great with KMP. You can do it, and there are even libraries that simplify this. But surprisingly to me, I learned that it's also possible to use KMP with, for example, MVP. So if your project has a more conservative structure, you can introduce KMP as well, and not necessarily rebuild it. One option that would probably not work is MVC, but you don't want to do it even in a regular app. So please don't do MVC. All in all, it's up to you what architecture you want to use for a KMP project. The most important thing is that you keep it similar on both platforms. Only in this case, you will be able to make it sustainable. At first, creating neat, organized architecture may take more effort and time, but in the long run, it provides more efficiency when it comes to bug fixing and guaranteeing the same behavior on both platforms. It will also stimulate the exchange between Android and iOS developers. Now let's talk about the other layer, the UI layer. Historically, in Android, we've been using XML files to describe the UI. With MVC and MVP, we'd use setters to manage the view and how they were reacting to the user input. It's a lot of management, bloats the code base, and can get quite confusing. With MVVM, we made a step towards reactive design with observables and live data. We could also benefit from data binding, no more getters or setters or manual input management. And as you can see, the mobile world has been slowly moving towards reactive declarative UI. Instead of telling the UI what to do, we want to declare how it should look and let the rest be handled automatically. Such frameworks like React Native or Flutter started to appear, and they were using reactive UI straight away. But in Android, we were still using XML layouts. And let me ask you, do you really enjoy working with XML layouts? As for me, I think it can be fun sometimes, but also feels quite outdated. Some people say XML layouts were introduced to Android because it was easier to describe UI with XML rather than Java. But now we have Kotlin. And finally, one day, someone came up with an idea to write UI in Kotlin. And they called it Compose. Meanwhile, on the other side of mobile development, there was iOS and Swift UI. Speaking of Compose, to me it makes much more sense than XML layouts. It's convenient, it's flexible, and it's in your favorite language. What else can you wish for? Well, there is something else. Compose goes very well with KMP, and it's very similar to Swift UI. It makes the code much more readable for developers from both platforms. So if you're an Android developer, you can understand better what's happening in iOS. And if you're an iOS developer, you can take a look at Compose UI and do the same on your platform. The main idea is to describe your UI with code components. In Android, we define a piece of UI as a function, and in iOS, we use a struct. The difference between the platforms is that Compose uses annotations to generate code that helps it manage the UI tree, and the Swift UI toolchain doesn't generate code. In Swift UI, we implement the view protocol by providing a computed view property called body. This property returns the view tree that can be composed of multiple subviews. On both platforms, the components may hold mutable state variables and observe changes to those states. In Android, we can use mutable state_of to create a state variable, and in Swift UI, we use property wrappers like state. Both frameworks ensure that when a state changes, the new UI is rendered, or as we say in Android, recomposed. So reactive UI and KMP is a match made in heaven. Not only this approach makes UI development more fun, but it also guarantees a single source of truth, better UI management, and greater similarity between the platforms. As I said before, you can build your UI according to your choice of architecture. However, wouldn't it be nice to share an extra layer that communicates the changes between the data layer and the UI, say a view model layer? Then you'd need a tool that would let you connect the view model and the UI layer. So let's talk about streams, or how we can observe data from the UI layer. Even if you decide not to share your view model layer, for a multi-platform developer, it's still useful to learn about streams. In Android, we have several stream-based solutions like Live Data or RxJava Observable. And if you're using Compose, you can simply use those streams in your composables. These functions let you observe data state. So whenever the new value is emitted, it recomposes those parts where the state is used. Like, for example, in this piece of code where the count changes and then the text with the count recomposes every time. What about the Arias counterpart? On Arias, the most popular reactive UI frameworks are Combine and RxSwift. Combine declares publishers for values that can change over time and subscribers to receive those values from the publishers. In iOS 17, they will make it easier with the introduction of observable macro, which generates source code at compile time and adds observation support to the type. In RxSwift, they use observable just like in Android. So iOS developers who are familiar with RxSwift could try building an Android app or a multi-platform app using Rx Kotlin, which would reduce the learning effort. But I haven't mentioned one more tool yet that I found extremely convenient and well-suited for KMP. If you decide to share the view model layer, then there is nothing else that can stream data better than that. I wonder if you already guessed what I'm talking about. Right, I'm talking about Kotlin flows. With shared view models, your best option is to use Kotlin Flow to pass stuff over to the UI. In Android, you can simply collect the data as state, almost like before with live data or observables, but here you don't need any extra dependencies anymore. It comes with Kotlin. And as for Arias, the way I did it was using the help of an observer function. First, we need to introduce a state class that will bind the UI to the view model layer. We pass the callback to the observer function and use the published wrapper with observable object protocol to observe changes. And then we can use the state as observed object in Swift UI and withdraw the UI every time when there is a change in state. Of course, consuming flows in iOS is not yet as simple as in Android, and there are other approaches like wrapping the flow into cflow that returns a closable and then transforming them into publishers for iOS. But to sum up, as a multi-platform developer, you should learn about streams. Reactive UI needs a stream of data. If you decide to share the view model layer, then mastering Kotlin flows can make you a much better developer. I've already been talking for a while, but I haven't mentioned a quite important topic yet, the language. Of course, most of you are Android developers here and use either Java or Kotlin, hopefully Kotlin. Obviously, for KMP, you will need Kotlin. As an Android developer turning multi-platform, you'll also need to pick up Swift. Even if you don't want to touch Swift UI, it's better if you can understand what your iOS colleagues are creating. The same goes for iOS developers, but in this case, it's more difficult because shared code is essential for both platforms and for the UI, and you need to be interested in learning Kotlin as an iOS developer. So here you are, an Android or iOS developer developing in Kotlin or Swift. You know how to deal with the problems and where to look for answers if you're stuck, and you're in a familiar territory. But then suddenly you are submerged into this new world of Swift and Kotlin, and it's terra incognita for you. So you don't know what awaits. What if you fail? That's psychologically difficult, but at the same time very rewarding. Learning a new language is like gaining new superpowers. Moreover, it's not as scary as it may seem. In fact, Swift and Kotlin are like twin brothers. Check out this piece of code. How long does it take you to figure out where is Kotlin and where is Swift? I bet you already solved that. As for the UI, how difficult is it for an Android developer to find his way in iOS and vice versa? The namings in Swift UI and Compose are different, but the idea is similar. For example, these are some of the UI components. As you can see, they're like American and British English. Row, H stack, stack, Z stack, lazy row, lazy H stack. Styling also looks a bit different, but not dramatically. Let's say we want to tint our buttons in a different color. In Compose, you pass the color into the function as a parameter, and Swift UI uses view modifiers that wrap the given view and change the visuals. So as a multi-platform developer, you need to get familiar with both Swift and Kotlin. This can improve your understanding of the app architecture and facilitate communication between the team members. Kotlin and Swift are quite similar, so there is no need to be scared. There is even another pleasant bonus for iOS developers. You get to enjoy the perks of having a good IDE. Another important topic, both for KMM development and mobile development in general, is libraries and the importance of open source. KMP is becoming widespread rather quickly. Although still not everything can be implemented using native libraries, you can always try with expect actual implementations, but sometimes there is no need to reinvent the wheel. There is already a number of useful multi-platform libraries out there. Here is a list of my favorite libraries. Coin and Codeine for dependency injection, SQLite and Realm for local storage, Ktor and GraphQL for networking, multi-platform settings for persisting key value data, Kermit for login, Mocha resources for sharing multi-platform resources. And to be honest, I have really big love for this one because when I started working as an Android developer, we often had to search for inconsistencies between the strings in iOS and Android. And once you can share your resources, you no longer have to waste time on such annoying things. IceRock developers have come up with a number of other awesome libraries for almost everything you need in KMM. But these were just the libraries that have my special love. In fact, there are many more, and you can check out these repos to find something that will suit your needs. Moreover, you can also build your own KMP library. There are resources on how to do that. In the end, where would we be without open source? If everyone was trying to build everything from scratch without reusing the universal code base, we wouldn't be able to progress so quickly. So key point 7, learning how to use KMP libraries will help your project grow faster. Contributing to open source projects and libraries is important for knowledge sharing and KMP growth. It's good to remember that KMP is not only mobile. The biggest advantage of KMP is that you can do everything. You can even build a backend for your app. In my previous speech, I mentioned that KMM needs multi-platform developers. Being a multi-platform developer means having a versatile set of skills. If you're looking for a side project or you're just curious, I would suggest you try backend development with Kotlin. First, Kotlin is a splendid language to try backend development. Another advantage is code sharing. You can create a module containing your models and your API interface and share it with your server and the apps. Also, there is a number of Kotlin frameworks and toolkits for backend development. To sum up this section, Kotlin functionality goes beyond the Android development and building apps. Being a multi-platform mobile developer, it's good to have other KMP-related skills, especially backend development, because it serves every front-end platform. This will not only make you grow professionally, but also contribute to the quality of your projects. Moreover, it will improve communication between teams. Speaking of communication, now that we've covered the technical part, I want to touch upon soft skills. If your brain is thinking now, well, that's easy, so I won't pay attention, then I ask you to focus. It's 10 minutes left until the break. Because social skills play a great role in KMP projects. Well, just like in anything else that has to do with people. In multi-platform, everything is intertwined, so your performance heavily depends on how well your team works together. Shared code should support all platforms, meaning it should fit all developers. In a simplified case, Android and iOS. Therefore, communication is key. And unfortunately, this is missing in any Android developer roadmap I've seen. I found no section on communication. Somehow, many people think that it's enough to just know how to code. However, unless you're working on a solo project, software development is teamwork. Not to mention, it can be much more fun when done in a team rather than struggling alone. Look at this guy, a typical software developer in home office. And these guys are doing some code review. Who has more fun, the team or one solo developer? And whose code will be cleaner and more readable? What do you think? Another important part of a good KMP team is a competent and knowledgeable project manager who can link the developers and clearly communicate what is done, what has to be done, and what can be shared. The project manager should make sure that the resources are used effectively and the work is not duplicated. If you're working on a small startup, then it's likely that one of the developers will play the role of the project manager. One more, or actually two things that I'd like to notice is openness and support. When you're learning something new, there is a lot of stuff you don't know. And no matter how much you learn, there will always be something you don't know. But there are also plenty of ideas that have to be tested. Sometimes we might think that our ideas are stupid or unworthy, and we're afraid of being judged. So we let those ideas go without even sharing them with our teammates. But it's a counterintuitive approach because no ideas means no progress. Instead, we have to be open with our colleagues. Cultivate the culture in your team when you're not afraid to discuss questions and suggestions that may seem stupid because they may turn out to be genius. So don't assume, don't be afraid to ask stupid questions, and don't judge. So once again, key point 9, communication between team members in a KMP project is even more important than in a traditional project because all parts are interconnected through the shared code. Try to make your communication as transparent as possible. Have a single source of truth. Yes, this rule applies not only to the code base. In regular cases, that will be your project manager or product owner. Share not only code, but also ideas. And practice empathy. I remember my PhD friends telling about how frustrated a scientist can be when doing research. When you try something time after time and you fail every time, it can really demotivate you. However, science is all about not giving up, and software development can be like that as well, especially when you work with emerging technologies. Even though it doesn't make it easier, it's really worth remembering that motivation is one of the scarcest resources. People tend to stick to their old ways, but this inhibits progress. I started this speech with the quote by Grasshopper, "The most dangerous phrase is, we've always done it this way." Well, sometimes you have to change your ways, but for that you need to learn, and you need to learn quickly. That's why I hope the map that I've come up with will help you on your KMP learning path. Let's revise the route quickly. First, research before you code and create your KMP project. Then learn Gradle and get used to multi-modularity. Remember, the most important thing is to keep your architecture clean, organized, and have similar structure on both platforms. Make your UI reactive. It provides better UI management and greater similarity between the platforms. Get familiar with data streams and especially Kotlin flows. Engage both with Swift and Kotlin. It will make you a better multi-platform developer. Use and contribute to open source KMP libraries. Try backend developer shoes. And finally, don't forget, we're all humans. Be a good teammate, share ideas, and be supportive. I didn't have enough time to go deeply into every topic on this map, like backend development, but I hope it will help you further on your KMP journey. And thanks for listening. Enjoy your time at the conference and in New York. And if you want to talk about KMP, skiing, or tennis, then you can find me around. Thanks.